Hey, welcome back, guys. I hope my voice is audible now. I think so. Anything problem, you can chat with me. So today I'm going to explain some problems related to collision. So the first question is like this. So the first question, it will take much time. Don't worry about it. So a rifle of mass M shoots a bullet of mass M of mass small m at a stationary block of mass capital M. So a rifle of mass M and bullet of small mass M coming and hitting the capital mass. Capital mass which is at a distance capital D away from it. When bullet moves small d distance bullet moves small d distance. 1 minute. The distance. Then asking to find and the distance, the small d distance towards the black M, BLOCK black. Then center of mass of the bullet system is at a distance, is asking. So this is center of mass. This question belongs to center of mass. Center of mass of bullet and black system. Bullet and BLOCK black system. But here center of mass problems and collision problems we can't deal separately. So compulsory we have to go with combined. Now see this answer. So there is a capital M here, a block of mass M. So which is at rest, that means U2 is equal to 0, initially at rest. And here is the gun rifle shooting the bullet of mass M. And initially the distance between these two is D. Initially the distance between these two is D. So now the bullet is moved the distance small d, that means the bullet is coming here. Then asking center of mass of the bullet and black system. So we know center of mass is equal to m1 into x1 in this case, m2 into x2 by m1 plus m2. So now that is equal to, so m1 means small m, and see if it is the initial point, this is the initial point 0, 0. At the instant when bullet is in the distance d, this is d, 0 will come. This mass coordinates are d, 0. In center of mass already we know that equal to small d plus capital M into capital D by small m plus capital M. So this is center of mass. But for suppose the question is like this. Question is center of mass from black of mass m, black from black. From here they are asked. Means from here to, so from here the center of mass in the distance, so somewhere here. So this is center of mass, the distance is here. From here they are asked to find out. So that is I can write d minus, means, so here is the center of mass from here initially. So now from here they are asking the value. This distance is equal to capital D minus center of mass distance. Capital D minus center of mass distance is equal to m into d plus capital M into d by small m plus capital M. So that implies, so small m into capital D plus capital M into d minus small m into small d minus capital M into capital D by m plus m. So small m into, sorry, capital M into d get cancelled. This is not cancelled. So these two are get cancelled. So this is m plus m. So therefore m into capital D minus small d by small m plus capital M is the answer. This is the center of mass distance from capital from the black, and means capital M. So I want to check, I'm pausing this. I want to check it is coming or not. Vaishnavi, Welcome back, guys. So this is one question. The next question is, so from the rifle they are asking. So from this distance already, from the rifle is MD. This is from the rifle. This is from rifle. So now from the bullet. So here is the bullet. So this distance I want to find out. So now from the bullet means from the bullet it will come like this. So that means, so here you can see from the bullet this is. So this is already center of mass point. Therefore, center of mass point, that means MD plus capital M into D by capital M small m minus small d from the bullet. That is equal to, so small md plus capital M into capital D minus capital M into small d minus small m into d by m plus n. So which is the answer? That is equal to capital M into capital D minus small d by capital M plus small m. So this is related to center of mass question. This is from bullet. This is from black. Right. So coming into next question. So for typing it is taking much time. So in the same models will go. So for suppose let's take another question number 2. So particle of mass m moving with a, so there is a particle of mass m and moving with a velocity 3i plus 2j. 3i cap plus 2j cap. So it is not coming. So we have to go to 3i cap plus 2j cap. So this is colliding with a, this collide with a, collides, sorry for the inconvenience. Is colliding with stationary particle of mass m of mass capital M. And finally, This first particle moves with velocity minus 2i cap plus j cap. So the question is, if masses are in the ratio, if small m by capital M is equal to 1 by 3 in the ratio, then asking the question, first question is the impulse received by the m. That means impulse j, impulse received by m, small m. So impulse means change in momentum, that implies m of v1 bar minus v1 bar. So depends on the velocity direction. Here velocities are vector, therefore negative is coming means negative, positive is coming means positive will substitute here. Magnitudes will substitute here. So now, so m into already is given, the particle after colliding is moving with, means this is the first one only, small m only is moving, not the capital M. So that equal to how much will come? So m into v1, v1 is equal to here given already, v1 bar minus 2i cap plus j cap and minus 3i cap minus 2j cap, that is equal to small m into minus 5i cap and minus j cap. That means direction is opposite, minus of the impulse is acting opposite to the initial direction, initial plane direction, right? M into 5i cap plus j cap. So this is impulse imparted to the first part. Similarly, the next question is the impulse imparted to or velocity of m. They're asking the velocity of m. So velocity of m, actually velocity I cap j cap is not given, means you can find out v2. V2 is asking to find out v2 formula. Otherwise, by applying the conservation of momentum, we can find out. So means velocity of capital M. So that is small m into 3i cap plus 2j cap, initial momentum, plus 0 is equal to final momentum. Small m into minus 2i cap plus j cap plus capital M into v bar. So this will become like this. This side is coming means m into 5i cap, and here minus will become plus of 5i cap plus j cap is equal to capital M into v bar. So now the ratio of small m by means the velocity v bar is only asking, that implies the velocity v bar is equal to small m by capital M into 5i cap plus j cap. So this value 1 by 3 is given, that equal to 1 by 3 into this answer. So this is answer. So understand this. This is a simple question, very easy. And they can ask kinetic energies also. Kinetic energies means velocities came, magnitude you will find out, and we will find out the kinetic energies. So kinetic energy gained by the capital M. So kinetic energy gained by the capital M is equal to kinetic energy loosened by the first particle. So here next question is, means place is there now, so I am writing here. So kinetic energy gained by capital M, stationary particle. So which is equal to kinetic energy lost by or retained. We can say this is retained energy. The subtraction of kinetic energy of the first body is called retained kinetic energy, or transmitted to second body. The first body how much is retained, so that amount will be means remaining from the first, and this subtraction means we'll get the second body gained. So the kinetic energy lost is different. Okay, now retained is different. So retained and lost by the first body, both are same. So gain by the second one and transfer the second one is same only. So kinetic energy lost by small m, both are equal. So it is easy to find out kinetic energy. So kinetic energy of the first one, if I want to means capital M means that equal to 1 by 2 m into v square, because initially 0, right? So that equal to 1 by 2 into capital M into, so here v is equal to, so here magnitude of V I want to find out. Magnitude of V bar is equal to, here already V bar I got, that equal to 1 by 3 into the root over 26. So I hope you remember in vectors, when vector is k multiples of another vector, then its magnitude also k multiples of that magnitude. So in vectors, multiplication of vector with a scalar number. So this will be magnitude also same times, k times multiplied means k times magnitude is increased. So m into v square equal to 26 by 9. So that equal to 13 m by 9 joules. So this is kinetic energy. Kinetic energy last also equal. So that equal to 1 by 2 m of 1 by 2 small m into v1 square minus u1 square. So that is equal to 13 m by 9. Okay, then v1 square minus v2 square we can find out. Okay, v1 square minus v2 square, because m by m 1 by 3 is given, therefore 26 by 27. The v1 square minus v1 square equal to, so here small m by capital M is equal to given, the small m by capital M 1 by 3, then capital M by small m is equal to 3 will come. So that equal to 26 by 3 joules of energy. If you want to check means you can check here. This is small m final velocity and initial velocity they are given. By that also v1 square and v2 square can find minus v1 square. So this is answer. Next, the next question is, so here one important question I want to discuss. So sometimes they will ask what is the kinetic energy or energy of the particle during the collision, they will ask. During the collision. So the question is like this. A particle moving with initial kinetic energy. Moving with initial Ke 3 joules. So whenever you are writing the symbol of scientist, you have to follow capital letters. That is in instant dimensional study. So this one, make a head-on collision. So head-on collision means that is one-dimensional collision. Means line of impact on same line. Head-on collision with a stationary particle. For simple calculation and all, maximum cases they will go stationary. If it is not stationary particle, calculation will become very big. And this particle have twice the mass. Which one? Projectile means which is participating in collision, means colloidal projectile. Colloidal means which is coming and hitting. That is colloidal. Projectile means which is undergoes the collision. So that means diagram I will draw, see, then you will understand. So the particle moving with initial kinetic energy. So here instead of velocity is given kinetic energy. Sometimes momentum we will give. So that also I explained already in another video. You can check. So now this is, let mass m. This one mass is m. Then here is the 2m mass. Double the mass which is at rest stationary. That equal to u2 is equal to 0. And the question is minimum kinetic energy of the system. Here the question is the minimum kinetic energy of system during impact. So during the impact, this is clue is given in the question. During the impact means both bodies, particles have same mass, same velocity, sorry, not same mass. This is 2m and m. Whatever the mass is, velocity is same during the impact. And the change in velocity take place in very short interval. That is called impulsive force. We studied already in another video, right? So therefore, is asking minimum kinetic energy. Therefore, kinetic energy in this case is equal to 1 by 2 m plus 2m 3m into v square. So I want to find out v value. So no other go conservation of momentum I follow. According to conservation of momentum. So m into, so here given kinetic energy. That means 3 is equal to 1 by 2 mv square. So then v1 means this is v1. v1 is u1 before collision. u1 is equal to the root over 6 by m. So that equal here anyhow momentum only now, that equal to root over kinetic energy means it will be cancelled, but root over 6 by m conservation of momentum is equal to 3m into v. So this m that get cancelled. Therefore v is equal to here 1 by 3 into root over 6 by m. I am not sending inside and all nonsense. I am not doing anyhow, square rule I will do now. So therefore kinetic energy here during the minimum kinetic energy is equal to 1 by 2 into, so 3 by m or 3m into 1 by 9 into 6 by m. So 3m get cancelled means 3. 3 1 ja, 3 2 ja, 2 1 ja. That equal to 1 joule. This is kinetic energy, minimum kinetic energy. kinetic energy minimum. So where kinetic energy is minimum means potential energy is maximum. The next question is what is the potential maximum potential energy? Maximum potential energy during impact. During impact. So here you can tell that potential energy is zero because these two are in contact, no reference line, not from the ground like that now. So initially the energy is equal to 3 joules, right? So now during the impact only 1 joule of kinetic energy is there for the particles, right? Only 1 joule minimum and maximum is 1 joule only. So now what about the remaining 2 joules? So that is maybe potential energy, or sound energy or heat energy. So that can be the maximum potential energy, or this potential energy is converting into sound energy or some other energies, right? Here ask to potential energy. They can ask here sound energy or heat energy is equal to how much? Or with this much of energy, how much temperature of any one particle is rises? Like that type of questions they can include here, right? So they may. That means the energy is conserved and according to conservation of energy. So now so therefore maximum potential energy is equal to 3 is equal to initial energy is equal to maximum potential energy plus kinetic energy minimum. So that equal to 2 joules will come. 3. This is already 1 joule, therefore 2 joules. Understand? Here momentum is conserved and energy also conserved. So coming into next question, next model. So related to here energy is given, right? So related to momentum, I will tell 2 questions. See now. So whereas related to momentum, a body X, name the body first one X with a momentum T collides with another stationary body named as Y one dimensionally. So during the collision, so again here during the collision, during the collision, during the collision means both masses have same velocity. Y gives impulse. Impulse means change in momentum. Y gives impulse to body X. In change in momentum of X body is equal to J. Change in momentum of X body is equal to J. Then coefficient of restitution here. Coefficient of restitution is asking question mark. So coming into So here see once. So this is collision of mass means body X and its mass is equal to m, consider, and there is another body of Y. So its velocity masses are not given here, remember that it is 0, u2 is equal to 0, and this particle momentum is given p, that means p is equal to m into v, m1 into v. I can go. So now during the collision, both the blocks are in same velocity, are with the same velocity x and y. The velocity is same. Therefore, the change in momentum J is equal to m1 of v1 minus u1. So in one dimension only, right? So this is J. We know that coefficient of restitution E is equal to J into reformation by J into deformation. J into reformation by J into deformation. If you take here, so J into deformation, so coming into the bodies, so after collision, so E is equal to, we know formula, V2 minus V1 by U1 minus U2. So now let's consider the impulse is given to the X is J by the Y. So this is J is same between Y and, so now if you go like this, so V means initial momentum mv plus J is equal to final momentum. Initial momentum plus J equal to final momentum, that is equal to mv1, m1 v1. So here identical particles is given. So both have same mass. So m1 m1 or m we can take. Here in the question I have written mistake in there. The colloids here another identical stationary particle. Another identical stationary particle. So m1 equal to m. So this is equation 1 we consider. So now coming into initial, it is a rest, therefore initial momentum is 0 plus J is equal to m into V2. So V2 is equal to J by m. So and here see this J is positive on Y, means this J is negative, therefore here J bar you take. So then clarity will come. Therefore here V1 is equal to, from this, P by M minus J by M. So U1 is also P by M, U2 is equal to 0. Therefore E is equal to, that implies E is equal to V1 V2 minus V1. Therefore J by M minus of V1. Therefore plus J by M minus P by M by U1 is equal to here P by M. U1, this is U1. So that implies U1 is equal to P by M. So here P by M. So that is equal to 2J by M into M by P minus P by M into M by P. So this will become 1. M get cancelled. So the final answer is equal to 2J by P minus 1. This is the impulse concept. So you understand this. So on the same type of model, one more momentum question I will explain you. So J concept only. When momentums are given, instead of velocities, momentums are given. How to find out the given answer for the given question. Now question see now. So understanding the question is important. The particle of mass m and momentum p bar, momentum p moves on a smooth horizontal table and collides directly and elastically with a similar particle having momentum minus 2p bar means it opposite direction. The gain in kinetic energy of the first particle is is given by so like this. The E is equal to xp square by x minus 1 into m. So now x is equal to how much they are asking. So if we coming into this question, the read question clearly, a particle of mass m, momentum p. There is a particle of mass m, its momentum p. And there is similar particle with momentum 2p, opposite direction. Similar particle means mass m. So collision is elastic between them. Therefore, conservation of momentum, conservation of energy, both are valid. The gain in kinetic energy of the first particle. That means the change in kinetic gain means change in kinetic energy. So that equal to 1 by 2 m into v1 square minus v1 square is equal to given x into p square by x minus 1 into m. So if you see here, kinetic energy is in the form of p square by 2m. So like that it has to come. We'll see now. So coming into answer, so V1 formula we know, V1 is equal to, and here stationary particle is given, direct elastic with a similar particle having momentum. Momentum is given, so it is not stationary, right? So M minus M into M1 minus M2 into similar particles, no? Into U1. So this is 0 plus 2 M2 U2. U2 means I can write 2P by M by total mass is 2M. So this 2M get cancelled. Here it is 0. So that equal to 2P by M. So V1 square equal to how much? 2P by M. So therefore kinetic energy 1 by 2 M into V1 square means 4P square 4P square by M minus P square by, okay. So that is equal to, so M get cancelled. Yes, sorry, M square, here M square. So this M get cancelled means M remaining. Therefore 3P square by 2M. This is answer. So according to given condition, then X is equal to 3 will come. 3 minus 1, X equal to 3. Correct answer. So this is answer. Momentum related question. So instead of velocities, momentum will give, or instead of velocity, kinetic energy will give. So that model is over. So now related to the impulse only, one more question I will give related to impulsive model. Impulsive model. In the collision concept, I related to concept of collision and impulsive one model, impulsive concept I have given in one of the video. That video will post after this problem is completed, right? Now question is, so typing the question is taking much time, so I'm going to directly the problem, try to understand. So here there is a ball of mass M is equal to 100 grams. 100 grams, 200 grams, 300 grams, kg, whatever. So here M is equal 100 grams is given. Suspended from a point, it is suspended from a point by an inextensible thread of length L. So this is one ball of mass. Now ball is drawn aside and held at the same level of A. So from A it is suspended, held aside and put the same level of A. In the distance from A, so given that root 3 L by 2. Root 3 L by 2. By seeing this value is given for calculation of theta. So now this one released. Now the ball is released. So now questions are like this. This is the given data. Now released. Released means it will come oscillates about this point here, right? We know that oscillates, or it will be depends on the given means depends on its velocity and all, it will rotate. Maximum oscillate only possible. It will oscillate only, in that no doubt at all. So now the condition is given and asking the question. First question. The velocity of ball. Velocity of ball just before jerk is. So the clue is given just before jerk. So generally, in the maximum of the cases, when I am trying also initially, so just before the jerk, This will be L length only. Jerk means it will become taut now. Here some loosen is there, less length. So now it become taut. Just before jerk, the velocity will be downward direction. Not it is coming from here now. So velocity will take like this direction. That is wrong. So velocity is in this direction. This is the velocity. This is clear. It is coming from this point. So this point, how much distance x we have to find out. Therefore, here velocity is equal to, means conservation of energy will apply here, of m into v square is equal to mgh. So h you need to find out. So this is L and this is root 3 L by 2. Therefore, here theta you find out. From the diagram, adjacent side for theta I know and hypotenuse I know. Therefore, cos theta I will find out. Cos theta is equal to adjacent root 3 L by 2 into hypotenuse. By hypotenuse, that is equal to L get cancelled, root 3 by 2. Therefore, theta is equal to 30 degrees. So now I want h value. That's why I will take sin theta. Sin theta into hypotenuse is equal to h. That equal to h is equal to L by 2. H is equal to L by 2. So now substitute the velocity initially. Therefore, m get cancelled. Then v square is equal to 2g h is equal to L by 2. That implies v is equal to root gr. So this is velocity before jerk. So now here this is the tensional impulse, here tension, and this is the perpendicular velocity which gives the centripetal force. The perpendicular component of this velocity will give the centripetal force. If tension is equal to this component, then it will stop here only. It will be in equilibrium and start oscillation. If tension is not equal to this component, this mv square by L plus mg cos theta, then it will oscillate. If these two components are equal, means these two components are equal, then it will be oscillate, because this component means I'm telling, see, this is the component velocity perpendicular to the tension, velocity parallel. Because of this velocity, centripetal force will come, and plus in the direction mg cos theta is there. Mg cos theta plus centripetal force mv parallel square by length r is equal to tension. Then it will be oscillate. Equal means there is no motion along this direction of string, therefore it will oscillate, right? So now after this, what is the velocity of ball after jerk? Velocity of the ball after jerk. Next question in this only. So just before jerk, this is case. After the jerk, the velocity will become like this. So next question. Velocity of ball after jerking. After jerk, the velocity for the particle will be in the direction v perpendicular. That is v perpendicular. So here this is 37. It is 53. Right? This one also 53. Therefore, the velocity after jerk is equal to, I will consider v dash, that equal to v into sine 37. Sine 53. This angle is 53 will come sine 53. Sorry. 30 means 60, 60, sine 60, sorry. So that equal to root 3 by 2 into velocity is equal to root g, root 2 gl. So that equal to root over 3 gl by 2. So this is velocity after gel. Now in this case impulse also they will ask next. Impulse means change in momentum. So impulse applied to the string means change in momentum along the string they are asking. Impulse applied by string is equal to how much? So now here impulse equation you have to take. So here along this direction impulse will take tension direction. So now tension resolve into components. Means J is resolved into components. So if we see J is equal to mv sin theta will come impulse in the after J. J is equal to, so here this is theta mv sin theta sin 30 will come, that equal to J is equal to impulse J is equal to mv. So in this direction, right? So cos 60 you can take or sin 30, whatever. Sin I have taken here, this is, so in the direction. So here is the theta I am considering, theta equal 30, then this is 60, therefore J equal to mv sin theta, that equal to m is 100 grams, therefore 0.1 kg into V means V I got root GL into sin 30 1 by 2, that is equal to, so here this is 0.05, otherwise root over GL by 20. So this is answer. So this is the impulse applied by string, means along the string impulse. So here J is equal to in this direction, parallel direction, mv cos 60 or mv sin 30, both are same. So this is about impulse case. So instead of impulse, in the same model of the question, so another question, see, another model of the question. So diagram is like this. So here it is fixed support. So initially there is a block of, means bob of massium, bob of massium. So from here it is coming from the height h. So here there is a 5 kg, 5 m mass is there, 5 m mass is there. So from height means from here, dragging here and left and releasing. So this is length L. So now it will become straight here, and when colliding case it will become straight. So length L. That means before collision, the bob of massium, before collision, the bob has velocity v. That means u1 is equal to root 2 gl. How we will get this is conservation of energy. Here L is the height. From L height it is coming to this point, bottom point. Therefore mg, here potential energy is there, here kinetic energy is there. Therefore u1 equal to 2 gl according to conservation of energy. So that and all you have to understand. If you want to means remaining videos you can see, right? So u2 is equal to 0. It is from the given condition. So now questions are like this. What questions will come? First, how much height the bob will rise again, backside bob will rise. So this is another question. So second question, what is the velocity of 5m mass after collision is on? 5m mass equal to question. Here in advance means one more problem means if you want to advance the concept. So this is on rough horizontal surface coefficient mu, something they will give mu. Then after, when the velocity becomes 0 for 5 kg, how much before coming into rest, how much distance it will travel? S is equal to, we'll tell v square by 2 mu g. 2a equal to mu g there. Application only, nothing. So now tension. Next question can ask, what is the tension? Tension in string. Okay, is how much? So now we'll see answers. So coming into here, U1 is there, U2 is there. Therefore, first to find out the answer for second question, velocity of the bob, velocity of the black. So velocity of the black, that is V2. The V2 formula is equal to here elastic collision. Therefore, E is equal to 1. V2 is equal to M2 minus M1 into 0. Therefore, 2 M1 into U1 by M1 plus M2, that equal to 6M. So 2M 6M get cancelled means 3. So that is V2 is equal to how much is coming here? U1 by 3, that equal root over 2GL by 3. This is answer. Similarly, find V1. Velocity of the bob after collision, that is V1. That equal to M1 minus M2 of U1. That is M1 minus M2. That equal to minus 4M into U1 by 6M. 2 by 3. That equal to 2 into root 2GL by 3. So this is velocity of bob V1. And here minus it is. Minus indicates that here heavier mass, right? 5M is heavier than M. That's why, and stationary, 5M is stationary, then the ball will be get reversed. Not rebounds means same velocity. Rebounds means no need to be same velocity, but maximum cases rebounds means same velocity will take. Here velocity is equal to this much I got. Now height is rising. Now it will not go to this height, right? Because it is less than initial velocity root 2GL. It is less than root 2GL. Therefore, it will not the rises to the same point. So it will become to here only. So for that height rise it is equal to maximum height, that is equal to V1 square by 2G. That is equal to V1 square is equal to 4 by 9. Kinetic energy never be negative. 4 by 9 into 2GL by 2G. That equal to 4L by 9 height. 9 meter. So this is the height raised from the origin is 4L by 9. So it is less than L. In that no doubt at all. So in the same question they can ask coefficient of restitution here. Already one we have taken. Then no need to find out. Tension in the string. See now tension in the string means tension is equal to here. It means immediate after collision. So just after the impact tension is asking. The tension, how much tension of in the string just after impact. Just after impact. That means here. So here tension. When it is here, tension is obvious. So now this is the length L string. Here bob is there. It has V1 velocity and mg. So therefore tension is equal to here mg plus mv1 square by L. So that is equal to mg plus m by L into V1 square. V1 I got 2 into root 2 GL by 3. Therefore V1 square equal to 4 into 2 GL by 9. So 8 by 9. LL get cancel here. So 8 mg means 9 plus 8 17. 17 mg by 17 mg by 9. So that equal to 17 by 9 approximately 2 mg. Sorry, mg. Approximately this is equal to x mg means 2 mg. So this is tension in the suit. So this is one model. Now another question. So this is somewhat related to concept of variable mass. So try to understand clearly. So there is a chute here which is giving the mass per rate. So sand is coming down with dm by dt which is equal to given q. So now here there is a one lorry is approaching with velocity v0 and the truck of this lorry has length L. Why this length L means see, if it is moving right, that means when it is coming here dm by dt, dm by dt, dm by dt, the velocity is varying. The velocity of the lorry is varying, final velocity. So if the means when it is moving, the total to remove the chute means here some sand from the chute. The time taken by the lorry to cover this distance, L distance, means lorry L length is there. Within the time, the total sand has to come. Otherwise, sand we have to stop the working of chute. Otherwise, it will fell down right down. So to avoid that, that is the reason here L is given. That point is important here. So now here the question is, okay, now it is moving, approaching. This lorry is approaching toward the this conveyor belt or this is chute, which is releasing the sand. And when sand is falling into the lorry, the velocity of the lorry is changing, right? Mass is increasing now. For conservation of momentum, here no external force. Therefore, conservation of momentum is taken place. If this is not short space, conservation of energy will go. First, we will go with conservation of momentum. So, from the conservation of momentum, initial momentum is equal to mass of the lorry is equal to m0 and v0 initial momentum is equal to the final momentum of the body is equal to m0 and total sand, that will be q into t. The total mass of the sand is removed and filled in the lorry. So by that time its velocity is equal to changing dv by dt. The velocity of lorry, this is velocity of the lorry changing from v0 to v. v0 to v final. Okay. When slowly here some mass, here some mass, therefore velocity changes with respect to mass after filling. Therefore, now m naught v naught into delta T is equal to m naught plus Q2 into dV. So now m naught by m naught plus Q into T, so into dt is equal to dV by V naught. So now integral dV I am doing. So here m naught V naught only keep. Integral dV we can do now. So here it is not V, right? Huh? So this V naught is constant. Initial velocity is constant here. So now integration here. So m naught V naught is, so if I take common, integral dt by m naught into qt. So from dv, integral dv from v naught to v, this is, and here mass is equal to m naught to m will come, right? Now m naught to m naught plus qt. These are the integrations. So now let m naught plus q into t is equal to m naught plus q into t is equal to some x consider. Therefore q into dt is equal to dx. Then dt is equal to x by q, dx by q. And the limits are t is equal to 0. Here t is equal to 0. This is the integration t, 0 to t will take integrations here. So 0 to t I will take, not mass. Integration in terms of t, therefore 0 to t. So 0 to t. So now t equal to 0, therefore x is equal to m naught, where t is equal to 0 limit. So where t equal to t, x is equal to m naught plus qt. So again the same thing will come, therefore m naught v naught. So in the place of dt I can write dx by q, therefore q will come integral m naught to m naught plus qt into 1 by x dx. So that is equal to integral the velocity of this one dm by dt, therefore initially 0 and finally v dv. So now 1 by x means log x or ln x, that equal to m v naught by q. So this is q by into log of, so here x is equal to log x. Integrations are log a minus b is equal to m into q naught t by m naught is equal to v. So now log of this m into q plus t total mass, final mass I will take, therefore m by m naught is equal to qv. So here v is equal to L into t I can take, that equal to by m v naught, m naught v naught. So therefore m is equal to, so here means final mass or mass, total mass is asking to find out. suppose the mass of the car and its load at the instant of time. This is what? Mass of the lorry plus sand, total sand, right? So that I have taken m here. So m by m naught is equal to log I am removing, therefore e power q into v at the instant of the velocity is equal to the time taken is equal to this t. In this time t, the velocity will become L by mv naught m naught v naught. Therefore m is equal to here. Therefore finally mass of the cart is equal to m naught into e power q into L by m naught v naught. Suppose what is the velocity, final velocity of this one. So here only you can stop. Otherwise, in terms of e powers, I want to find out means. So final velocity v, let consider that equal to m into v dash is equal to m naught v naught according to conservation of momentum. That is v dash is equal to m into v naught, m naught v naught by m. M is equal to here by m. That equal to m naught e into that answer. So that equal to m naught get cancelled. Therefore v naught into e power minus q into L by m naught into v naught. This is final velocity of the cart at the instant of time t time. T equal to 1 second, consider like that, instant of time in terms of t. So this is related to collision. So now very simple question in oblique collision I'll discuss. I'll start discussing oblique collision. Very simple one. There are 3 or 4 models of questions are there. Maximum I'll try to explain the questions here, that model. So here 2 equal identical spheres are there. One is B, the other one is C. So another identical mass A is coming to collide. This is A, and a collision taken place. All are same size, but BC mass is same size. Same size means radius are equal. Why I am telling same size? Same size means mass is not equal here. So this is m by 2. So if you take B and C are m, now A is equal to m by 2 mass, but means radius are same. Therefore, from this case, here you will find out the angle C. That is why same size I am telling. Same size means this is 2R equilateral triangle. Therefore, this angle will become 30. This total is 60. Therefore, this angle alone 30. So this collision is elastic, no? Symmetrically impinges. That means the ball B will go like this direction with VB, and ball C will come in this direction, that is VC, and VB is equal to VC. VB is equal to VC. And now in the horizontal direction there is no external force. Therefore, first I will find out the VB, VC velocities and final velocity of this one. And this is after collision. This A is coming into rest. Therefore, m by 2 into initial velocity u1 is equal to, these two are moving in the same velocity. I will consider the velocity acquired by each sphere B and C is same velocity. Then that equal to 2m into V cos 30. You understand, right? 2m into V cos 30. So get cancelled. So then velocity of this u1 is equal to u1 is given means you will substitute V value, otherwise u1 in terms of V I am finding, right? Therefore u1 is equal to 4V into root 3 by 2. So that equal to 2 root 3 into V. That implies V is equal to, means velocity is u by 2 root 3. Understand? This is velocity of ball B and ball C. So now I want to find out the coefficient of restitution. So E is equal to, I know, V2 minus V1 along the common normal by U1 minus V2 along the common normal. The oblique collision, common normal you have to take. For this is first particle, this is second, or this is second. Anyone you take, no problem. Between the balls is asking. Therefore, E is equal to. So now this is the common normal, right? This collision is common tangent here. This is common tangent. Then this is common normal. So in this direction, common normal direction, the U have velocity. This is U means U cos 30. So U1 along the normal, U2 is equal to 0. Therefore V2 and V1 is equal to 0. Therefore V2 normal is equal to V by U1 normal is equal to U cos 30. So already we know V is equal to U by root 3. So substitute now U by 2 root 3 into U into root 3 by 2. So 2 get cancelled, U get cancelled. That equal to E is equal to 1 by 3. This is answer. So loss of the kinetic energy during the collision. Loss of kinetic energy is equal to gain of kinetic energy by the two bodies. So that is equal to how much will come? So if we solve that, we will get mu square by 6 kinetic energy, right? Solve these equations, values by substituting, we will get mu square by 6. I want to explain. So the gain in kinetic energy, therefore the loss in kinetic energy by the particle A is equal to gain in kinetic energy by particle B and C. So that equal to 1 by 2 into 2m into the gain in kinetic energy or loss in kinetic energy. Gain in kinetic energy 1 by 2, 2m into the V square. So that equal to m into V square is equal to V square by 4 into 3. So that equal to mu square by mu square by 2m only. No, this is answer 2m. And initial kinetic energy also, the loss in kinetic energy during the collision. So here loss in this is the gain in kinetic energy by blocks, right? By B and C, this is that equal to mu square by 2. So now suppose loss in kinetic energy in the system. Next question, loss in kinetic energy in collision, during the collision. Loss in kinetic energy. It is not asked that, means here E value is there. No? E value is equal to 1 by 3 means semi-elastic collision. There will be a loss in kinetic energy. Kinetic energy is not conserved. Therefore, loss in kinetic energy of the system is asked. Loss in kinetic energy in collision, not specifically in one of the body. So, this is a loss in kinetic energy by first body or gain in kinetic energy by B and C. So, in this case, that is initially 1 by 2 into m by 2 into u square. Now, finally, mu square by 12. This is loss in kinetic energy, delta Ke. So, this can be converted into any form of other forms of energy, either potential energy or sound, heat, whatever. That equal to 4 and 12, LCM is 12. 2 mu square by 12 will come. So, that equal to mu square by 6. So, this is loss in kinetic energy in the collision. Mu square by 12 gain or loss in the kinetic energy of the first body or gain of the kinetic energy by the B and C problem, B and C balls or spheres or bodies. So, the question what is asking that we need to find, that we have to understand clearly, then only answers will come correct. In options they will give mu square by 12, mu square by 6 and mu square by 4, something they will give, right? Mu square by 4. So, those values are what? And question is asking what? So, by seeing mu square by 4, okay, answer can keep A. So, there we have to take care what the question they are asking clearly. So, now in oblique collision between the spherical balls, see one type of question I will explain. Next to go, next model. This is one question. Next to go, next model. This is clue is given in the question. During the impact means the same way the question will come like this. Another question. So, two identical balls A and B. So, this is ball A, identical ball A and B. So, those two are coming like this, A and identical ball B. And V is equal to, they are coming with V, the V equal to 2 root 3. Both are coming with the same velocity. And here angle is 60 degrees. Collide instantly at point C. Here a point C, they collide. Those two are collide. So they combined here. Means this collision is inelastic collision. So combined. And these two are moving with velocity V is how much? Same conservation of momentum. So that equal to 2m into the V is equal to, in horizontal direction momentum is conserved. No change in, no impulse. So impulse will be perpendicular. In the direction only there will be a J. So in impulse concept is important. So now here no need, this is horizontal in horizontal direction. 2mv is equal to, so both are identical particles, therefore 2m into, so this is 60 means symmetrically 30 degrees will come. This is 30 degrees will come. Therefore 2v, 2m into v, not 2v, 2m into v cos 30. Cos 30 means root 3 by 2. Directly I am writing 2m get cancelled. Therefore, the final velocity v is equal to, so initial velocity v is equal to given 2 root 3. Therefore, 2 root 3 into root 3 by 2. So 2 get cancelled. That equal to 3 meters second. So you understand this, right? So next model of question. So coming into collision between two spherical balls. Consider here two spherical balls of identical mass. This is important point that remember. Collides elastically another identical ball. So with rest. So this is ball A and ball B, which is at rest. E2 is equal to 0. So here the concept is the equal masses. Already this note I have given. Equal masses. One is at rest. One is at the rest. Collides. After collision, this is a note already in another video I have given. After collision, they must move perpendicularly. That means one is along. So the A is colliding B. So this is the velocity is given. 10 meters second is moving. So now after collision, this block will continue. B block will continue along the common normal. And A block will move along this direction. This is V1 and here V2 will come. Velocities are not same, but they will move perpendicularly. Means one is along the common normal, another one is along the common tangent. So this is the statement you must remember. And initially it is 10 meters second inverse A and 30 degrees with center is making. So now asking to find out the question 1, the velocity of A is equal to question after collision. So here 2 dimensions, right? Velocity of A is equal to VA tangent plus VA normal. VA normal is 0. It is not moving normally after collision, therefore VA tangent. So VA tangent is equal to initial velocity UA tangent. Why? In the common tangential direction, conservation of momentum takes place for the particle. There is no change in momentum. Impulse is not there along the common tangent. Along the common tangent, no impulse. No J. So that equal to UA tangent means, so this is in the direction V1. V1 is along the tangent only, therefore V1 is equal to U sin 30. U sin 30. So that equal to 10 into 1 by 2. 5 meters second. So how simple this is. But in some problems they will not give any value and they will ask direction of V, how they will move. So this explanation I have given in one of the video. You can check how they will move perpendicularly by they are moving. Note also given. The velocity of the ball B after collision. So velocity of the ball B. So V2. So V2 is equal to question mark. So if you see here conservation of momentum along the common normal, I will take V2 to find out. Conservation means along the common normal systems momentum is momentum of the system means both the particles, all the particles is conserved. That is all are equal mass only now. Therefore m into initially the velocity of along the common normal u cos 30 plus 0 is equal to m into v along the normal v2. Am get cancel? So that equal to u into root 3 by 2 is equal to v2. So that is equal to u already got, that is 10 is given. Therefore 5 root 3 meters seconds. So this is velocity of second ball B the direction. So and here it is 90 degrees. After collision, perpendicular means theta is equal to 90 degrees compulsory. And that is the condition two balls are in whatever the angle. Here 30 only no need. 60 also it can collide with the 60 degrees also. The A can collide with 60 degrees also, no problem at all. Whatever the angle, but total angle between A and B after collision, the directions A and B move in the direction mutual perpendicular, that is 90 degrees. Condition is that. So next question here. So before going to next question, I will take welcome back. Next question is like this. So there is a gun is mounted on a, so this is a railroad, rail car means it can move on rails. So there is a one gun is mounted here. So with the person, gun and the cells here. total 50 m, and the cell mass is m. Then question is, what they're asking is the recoil speed of the car. Recoil speed of car. Recoil speed of car after second shot. After second shot. So here no external force is coming, is there? Therefore momentum is conserved. So that I will follow. That means, so initially 50 m is at rest. 50 m into 0. Initial momentum is equal to 0. Now the shell is fired with velocity v. Then for velocity of the with 200 meters second was. The shell is each times shell is fired means shell means here bullet. Shell is fired with 200 meters second was each time. Then recoiling velocity of the car after second shot. This is the question. So initially 50 m total mass at rest. So m is fired with velocity. So that equal to 200 minus velocity plus remaining mass is equal to 49 into means 50 into m. It will go opposite direction, right? 50 into m, opposite direction with velocity v. This is, so this direction is positive I have taken means 200 is negative. Therefore minus 200 plus v and minus. So that implies 49 into v is equal to 200 into m. 49 m get cancelled. Therefore velocity of recoiling velocity of vehicle is equal to after first shot is equal to 200 by 49 after first shot. So now second shot after how much? So now see, now this is the cart with 49 m only. One shell is fired now, and it has a velocity in this direction minus velocity in the direction, the velocity of recoiling, and now second shot is ready to move with 200 meters second volts. So this is relative velocity. 200 meters second was the relative velocity of the shell. So therefore now 49 m into VR is equal to 49 m into P dash. 49 means 49 not 48. One cell is going now. 48 m into V dash plus the shell m into V minus 20. V is taken as positive, and this 200 is, this one is taken as positive direction, left direction. Then right direction is negative. So like that. So now MV will come this side. This is VR. VR minus. Therefore 48 m into VR plus m into 200 is equal to 48 m into V dash. M get cancelled. And we are already 200 by 49. Therefore this 40, yeah. Right. that equal to 48 into VR is equal to 200 by 49 plus 200 is equal to 48 V dash. Therefore, velocity after second shot is equal to this 48 get cancelled. Here 48 will come. For 200 LCM 1 by 49 plus 1 by 48. This is another model of problem. So now, so the last question I will tell. So the ball is projected. So here question is, the ball is projected vertically upwards. The ball of mass m projected vertically upwards with velocity from the ground u. Then questions are, and E is the coefficient of restitution between ball and, here E is coefficient of restitution. And now they are asking, questions are like this, they are asking the total distance traveled by the ball before coming to rest. Total distance means it is coming to rest. Total distance. And total time. Third one, average speed of the ball. Total momentum. You know average speed, total momentum. V average. V average means total distance by total time. This is equal to 1 by 2. And now fourth one, when V average, you know, impulse important. Impulse imparted to the ground. So generally in coefficient of restitution will drop the ball from some height. But here vertical projected. So it will go to here. So again it's coming into colliding. So this is the maximum height h it is go. So h maximum it will travel. Again come before collision, before the collision it will take 2 times of h. Therefore total distance traveled here. So if you have idea about the coefficient of restitution finding, the freely falling case, so that is another video concept case I explained there. So now see, so now total distance is equal to here 2 maximum height plus 2 into next maximum height, that equal to h1 plus 2 into h2 plus 2 into h3 and so on. So here h1 is equal to, you know, u square into h, right? So that equal to 2 into h is equal to u square by 2g. Otherwise keep h, afterwards we can write finally. Keep h only, plus 2 into e square h plus 2 into e power 4 into h plus 2 into e power 6 into h plus and so on. That equal to 2h take common, 1 plus e square plus e power 4 plus e power 6 plus and so on. So that equal to 2h into, so 1 plus e square, this is here in GP this is. So therefore the sum of these terms will become a by 1 minus r, that equal to 1 by 1 minus e square. So therefore a means 1 by 1 minus e square. So here h is equal to u square by 2g. Now we will substitute, that equal to u square by g into 1 minus e square. So whereas in freely falling body case, h is equal to, will get, means total distance, s is equal to h into, means dropping height is equal to dropping height into 1 plus e by 1 plus e by 1 minus e, 1 minus e square, 1 plus e square, 1 plus e square by 1 minus e square. This is answer you will get there. But in freely falling body, this is the answer, total distance traveled when coefficient of restitution is e. In case of projected body, this is the total distance traveled before coming into rest by the final collision. Now total time. So here therefore total time is equal to, in freely falling body, the freely falling from the height h, freely fall, and coefficient of is same nature, same ball, same ground, then t equal to here the root over 2h by g into 1 plus e by 1 minus e will come. So now how much will come in this case you will see. So here the answer will come like this. Total time t is equal to 2t1, time of ascent here, u by z, 2t1 plus 2t2 plus 2t3 plus and so on. So t1 equal to u by z. So here 2 into initially u by z, okay, plus 2 into here t2 is equal to here maximum height, right? Right, that equal to v1 by g, means v after first collision, means after going up with u by z time, u by z seconds, coming down before going to collision u by z, that is already before first collision it is taken 2 u by z time. Then next it is colliding, means colliding velocity changes into v1 and it is going to up, right? This is right. See, I will draw the diagram here. So first it is going up and coming down. So after colliding first collision, so here it is going up with initial velocity u, and now velocity v1 is changed. Again going up to maximum height, coming down, and again after second collision it will change it into v2. Therefore we know very clear the velocity after n rebounds is equal to e power n into u, initial velocity, v equal to e power n into u. So that is equal to plus 2 into v2 by g plus 2 into v3 by g plus and so on. So that equal to 2 u by g take common, u plus v1 is equal to e into first collision, e into u plus e square into u plus e cube into u plus and so on. So now 2 u by g total time when e is not there. So this is also 1 plus e square plus e cube plus and so on. This is also in GP with difference ratio is e. So that is equal to total time is equal to now 2 u by g into 1 by 1 minus e. So you can understand this, right? So this is the answers. Now average speed you can find out, right, by these two. Therefore average speed is equal to total distance u square by g into 1 minus e square by total time g into 1 minus e by 2u. U get cancelled, g get cancelled. So here one a minus b, a square minus b square. So here u by 2 into 1 plus e is the answer. So this is answer for average speed. u by 2 into 1 plus e. Here. So total momentum means m into will multiply, will get answer. This is total momentum imparted to the ground. But here total momentum is asking, or total momentum imparted to the ground means the change in momentum of first particle. First one, that equal to mu into the momentum imparted is equal to P is equal to mu into 1 plus c by 1 minus c will come. Means mu minus mv. So v already we got. V is equal to final momentum is equal to our speed we got now 2u by g into 1 minus c. What you do? Right. So now this is enough.